All right, so 7.6, the last lesson of Unit 7 is over. Inverses, elevation, and depression. And we're going to talk about that in just a second. But first, we're going to do some awesome bell work to make sure we understand and remember all of our trig ratios. So for number 1, we want to find the following ratios. We have sine A, cosine A, tangent A, sine B, cosine B, and tangent B, referring to this lovely triangle over here. So we're first going to find angle A over here, and we're going to look at sine A. Remember, sine is so we need opposite over hypotenuse. So we say 5 over 13. Looking at angle A, we're also going to look at cosine, which is ca, which is adjacent over hypotenuse. We're going to see that as 12 over 13. And lastly, for angle A, we're going to look at tangent, which is our TOA, which is opposite over adjacent. Just remembering our SOHCAHTOAs. So, our last 3 of this problem is looking at angle B. Once again, we're looking at sine of B, so where opposite is now 12, but our hypotenuse is still 13. So we say 12 over 13. Looking at cosine, our ca, the adjacent, 5 over our hypotenuse, 13. And our tangent, TOA, opposite, 12 over adjacent, 5. Again, just remembering all of that loveliness and trying to remember our SOHCAHTOAs. Okay? Alrighty. So, number 2 is saying we need to solve for our side length B and our side length C. We are given angle B and what side length A is. So we need to be able to remember how to find, using SOHCAHTOA, opposite side lengths. So we have this angle, we're going to start with B, that is opposite of 25, and we were given an adjacent. So that should show us that we are going to be using TOA, or tangent. So tangent of 25 equals opposite B over our adjacent 8. Okay? So we're going to solve for B. We're going to cross multiply. We're going to see B equals 8 tangent of 25. You're going to plug that into your calculator, and you're going to see that it is 3.73. And this says meters, so meters. Okay. Our last one we need to find is C, and C, because it's across from our 90, is our hypotenuse. We are given our adjacent, so we have AH, which is ca. So we're using cosine. So cosine of 25 equals adjacent 8 over our unknown hypotenuse C. So we're going to cross multiply and see that C cosine of 25 equals 8. And then we're going to divide by cosine of 25. So C is going to equal 8.83 meters. Okay? Please, I mean this, these are your calculators you want to use for this specific stuff. If you're trying to use the calculator on your iPad, you have to do 25 tangent, then times 8. I think for division, you're going to have to do 8 division, parentheses, 25 cosine, into your parentheses. So please, if you do, please use another form of calculator other than your iPad. Okay? So, today, we are learning about the inverse of all of this loveliness and how angle of elevation and depression helps us solve word problems. So first we need to know that is how can I utilize inverses to solve for degrees and elevation/depression with word problems? That is our essential question for today. So if trig functions find ratios, then inverse trig functions find degrees. So we're going to be able to find degrees of a triangle, of a right triangle, using inverse trig functions. It's not too complicated. So if sine theta equals so opposite over your hypotenuse, then sine inverse, to solve for the degree, is opposite over hypotenuse. So we're just, instead of saying sine theta equals opposite of over hypotenuse, theta equals sine inverse of opposite over hypotenuse. It is only one extra button on your calculator. Cosine, again, is co, so adjacent over hypotenuse. So cosine inverse is adjacent over hypotenuse. Tangent theta is opposite, because TOA, over adjacent. Therefore, tangent inverse is opposite over adjacent. So it's the same thing, it's just instead of looking for a ratio, you're now looking for a degree with the inverse of our trig functions. Okay? Same thing, just one extra button click, and I'll show you that in just a second. Our next thing is we're going to look at the angle of elevation. So the angle of elevation states that an object is seen by an observer is the angle between the horizontal, so the straight line, and the line from the object to the observer's line of sight. So this is saying if I am here on the ground and I look for an object up in the air, or I have to look up, this is my angle of elevation. Okay? That's my angle of elevation. Should be an N there. I'll get more into the examples in just a second. So the other one we need to look at is the angle of depression. And this is when the object is below the level of the observer. So instead of me looking up at something, I'm going to be looking down at something. Based off of my horizontal here, I'll be looking down to the object I am looking at. So this is the angle of depression. One thing you need to remember is that the angle of elevation has to equal the angle of depression. And you're going to see that in an example. But this is nice to know. Angle of elevation is the same thing as the angle of depression. All right, now we're getting into the nitty-gritty, looking at our actual examples. So these first four examples are finding those degrees we were talking about. So it's the same thing as what we've been doing, it's just now we're looking for the degree instead of a missing ratio. So since we have sine theta equals 8 over 14, and we're looking for theta, it says theta has to equal sine inverse of 8 over 14. Nothing changed, except now I'm doing sine inverse. So to do this in your calculator, you're going to have to go to second. So you press your second, and if you look right above sine, cosine, and theta, it says sine inverse, cosine inverse, and tangent of inverse. So we'll do sine inverse, and we'll put in 8 divided by 14. Pressed on instead of enter. And we're going to get 34.84. Okay? So it's just an extra button. You do second of your trig ratio that you're doing, and you plug everything in as you see fit. So this is 34.85 degrees. So that is the degree of the triangle based off of those two ratios. Okay. Looking for the degree of cosine theta equals 3/8. Same thing. We say theta has to equal cosine inverse of 3 over 8, which means you press the second button, cosine, and you put 3 divided by 8, and you're going to see theta equals 28.69 degrees. Okay? It's the only difference for inverses. 3 and 4, same thing, except now we have to determine which trig ratio to use. So we're looking for this angle of x and we are giving 4 and 7. 7 is across from the 90 degrees, so this is our hypotenuse. And 4 is touching our angle, so we are adjacent. We have HH, AH, which means we are using cosine. So we're going to say cosine of x equals our adjacent 4 over our 7 hypotenuse, and it looks just like what we did over there. So we say x equals cosine inverse of 4 over 7. We're going to plug that into our calculator. Second cosine, 4 divided by 7, to get 55.15 degrees. Same thing, okay? Number 4, we are given this angle here. We are given that 11 is touching it, so this is our adjacent. There is nothing on our hypotenuse opposite of our 90, and 6 is opposite of our angle. We have OA, so that means we have TOA. Okay, so it means we're using tangent. So we say tangent of our unknown x equals opposite of 6 over our adjacent of 11. Solving for x, it's the same thing as saying tangent inverse of 6 over 11. Go into your calculator. Second tangent, 6 divided by 11 is going to equal 28.69 degrees. Okay? Again, please use this calculator. It's so helpful. Now getting into your favorite, I know, word problems, but that's okay. We use these word problems to help us understand real world scenarios. So our first one is the Statue of Liberty is standing on a 150-foot pedestal. Awesome. So we have a little pedestal. It's 150 feet off the ground. From a point 250 feet from the base of the pedestal. Okay, so that says base of pedestal, about 250 feet away. The angle of elevation to the top of the Liberty's torch is 50, that's 50 degrees. So what that says is I must have a very tall statue here. I am going to look at from the horizontal, I'm on the ground, to the top, so I have an angle of elevation to the top of the tower, so it has to be this degree from the ground to our line of sight of 50 degrees. Okay? Now that we have done that, we want to find the height of the statue. So this is our unknown x, and we did create a right triangle. Now we have to, just like what we did on 3 and 4, figure out which ratio we're going to be using. So we were given 50. This is, our hypotenuse was not given. We have adjacent and we have opposite. So that means we're going to be using TOA, tangent. So tangent of our degree 50 has to equal opposite. Well, opposite, we have a 150-foot tall pedestal and an unknown. So this is just saying x plus 150, because it's just being added, over our adjacent 250. Okay, we solve for x. It's just cross multiplication once again. So we cross multiply, we're going to see x plus 150 equals 250 times tangent of 50, meaning we need to subtract 150 from both sides. So we're going to get 250 tangent of 50 minus 150. So this one again is going to be a little tricky to put in your calculator if you're using your iPad. You would have to do 50 tangent times 250. You're going to have to press enter and then subtract 150. You can't do it all in a row. On your calculator, if you do it straight in a row, you're going to put an end parentheses around your 50. So it's going to be 250 times tangent of 50 in parentheses minus 150. That minus 150 does not go with that 50. So when you plug that in, you're gonna see that x equals 147.9, and we've been doing everything in feet. So the Statue of Liberty is around 148 feet. Calculator work. If you plug it in your calculator, this is where everyone's gonna potentially get something a little finicky. So make sure 250 times tangent of 50, you end the parentheses, minus 150. If not, you're gonna get a really funky number and it's not gonna work, okay? All right, only 2 more to go. We're doing fantastic. Okay. So 6 from the top of a vertical cliff, 40 meters high. So all right, so we have a very tall cliff that is 40 meters high. The angle of depression, okay, so we have our horizontal. So we have a horizontal because this is where our original eyesight is. Angle of depression, so that means we have our eyesight go here to the base, that is an object, to the base of the cliff, okay? So we have the base of the cliff to the object, but we're looking here, and we're gonna see that it's gonna have a 34-degree angle of depression. So horizontal to an object, from here to here, so that means from our horizontal to our line of sight is 34 degrees. How far is the object from the base of the cliff? All this says is, even though you're not like, what is happening, is saying here to here. And we need to understand that if the object was looking at us, the angle of elevation is the exact same as our angle of depression. So if you know angle of depression and angle of elevation, they are the same thing, okay? So now we have enough given information to help us find what x equals, okay? I have been given that this is the angle we're looking for. Our hypotenuse was never given, so we have opposite and adjacent. So once again, we are dealing with TOA. So tangent of our known angle 34 equals opposite 40 over our adjacent x. Cross multiply, stuff we've been doing for some time. So we cross multiply to see that x tangent of 34 equals 40. We divide by tangent of 34 to get 40 divided by tangent of 34. Again, I talked about that at the beginning of this video. Make sure you're plugging that in correctly. When you plug it in, you're going to see that it is 59.3 meters. So our object is 59.3 meters away from the base of the cliff. So angle of depression. The only time your angle of depression is not looking like this one is if it says I start here and looking down at the object and I want to know how far away from the top to the bottom is. So that kind of looks like, here's my line of sight, here's my angle of depression, how far is it from this point to this point? And then you don't have to do the switcheroo, okay? So just as a reminder. One more lovely problem, and then we are done for this unit. How awesome is that? Okay. So our last one, a wheelchair ramp is placed over a set of stairs, as you can see from the picture, so that one end is 2 feet off the ground. The other end is at a point that is a horizontal distance of 28 feet. So it just says, here's our stairs, our ramp is about 28 from here to here. We don't know how long the ramp is. And we want to find the angle of elevation, so from the horizontal to the line of sight, so this, to the nearest 1/10 of a degree. We have been giving all of our information here in this picture. So we see that our ramp, which is our horizontal, was not given to us. So we see 2 feet is our O, and 28 is our adjacent. Apparently we really like tangent. So we're going again with our tangent of TOA. We see that tangent of our unknown theta equals opposite of 2 over adjacent of 28. We are looking for degrees. My projector came off. Well, just real quick, this is our last deal. I'm not sure what happened here at all. There it is, back, done. So, looking at our theta equals tangent inverse of 2/28. Again, just because it's theta, it's tan inverse of what it's equal to. You plug it in your calculator, second tangent, 2/28, has to equal 4.1 degree. And that kind of makes sense. You really don't want to go up a ramp at like 20 degrees. Not going to go very far. But 4.1 degree angle of elevation. Okay. If you have any questions, please come and see me. Ask questions, emails. Have a good rest of your day.